Since ancient times, humans have recognized that the silt and mud deposited by rivers are sources of life and wealth. However, this amphibian world, lacking in substance, a sort of malicious monster capable of sucking in and absorbing things forever, has always inspired fear and anxiety. What is this mud made of? Of very small particles of a mineral that plays the leading role, clay. An actor with strange properties. Formed by the disintegration of rock, clay is composed of microscopic layers formed themselves by the piling up of layers of aluminium and silica. Depending on the amount of water they entrap, clays undergo radical changes of state, from almost liquid to highly compact and impermeable mud, as well as the formidable quicksand. Mud has a quality that is unique on our planet. It contains all the building blocks necessary for life. The first stages of the creation of living matter, animal and plant, take place in mud, hidden from view. It is therefore a logical conclusion that it all began there, in this strange mobile interface between the continents and the oceans more than 4 billion years ago. Exposed to energy from the sun, mud enabled the development of not only life, but also its sinister but necessary counterpart, death. For millions of years, every life has nourished another life and is just one step in the great history of the world of the living, in a state of perpetual reconstruction. Studying the modalities and strategies for maintaining life is Daniel Guiral's passion. He's a researcher at the Development Research Institute. Daniel Guiral is a specialist in aquatic ecology with a deep interest in understanding the modes of life of the communities, both plant and animal, that have chosen to live, quite paradoxically from the human point of view, in such restrictive and uncertain environments. If there is one thing that the researcher finds hard to bear, it is not being able to understand the subtleties of life in this environment that he has chosen to study and which has been defying him for years. And even though he knows that obviously his own lifetime will not be sufficient time, he makes a desperate bid on each new mission to Guyana to reveal a few of the many mysteries of the circle of life. This time, Daniel had decided to set up a floating laboratory in the estuary of the Core River, close to the border between Brazil and French Guiana, and in the immediate proximity of a huge mudflat. This strategy will enable him to reduce to a minimum the interval between sampling and observation. He thus hopes to be able to observe the behaviors of the strange but fragile inhabitants of the mud, which will provide him perhaps with new paths for understanding life in such hostile and yet rich environments. But where does this mud come from? From the rivers of Guyana that flow to the shores of the western Atlantic Ocean and which seem to regurgitate this heavy mud, spreading it over hundreds of kilometers? No, this mud comes from further away, much further away, from the slow but inexorable erosion of a gigantic mountain range, the Cordillera de los Andes, the Andes Mountains, which extend for 7,500 kilometers along the Pacific Ocean and rise to almost 7,000 meters. Rain, snow, and intense frost relentlessly erode and dissolve the Andes. When the snow melts, the running water sweeps away the debris, at this point reduced to clays. Tens of thousands of tons are poured massively into the Amazon, then transported over more than 3,000 kilometers to the Atlantic Ocean. Taken up by the ocean currents, the clay is deposited along the coastlines from northern Brazil to Venezuela. The process of the development of life, infinitely complex and heir to a history spanning millions of years, finds in mud the ideal conditions for its realization. But what are the required ingredients? Energy? We are right on the equator. The sun is vertical all year round, with clouds providing the only shade. Water? On the coast of Guyana, there is a mixture of rainwater, river water, and seawater. Carbon? It is present in the air in the form of carbon dioxide, and especially in water in the form of carbonates. Finally, the nutritional elements essential for the fabrication of living cells: nitrogen and phosphorus. Absolutely, they are here, freely available since they are trapped in the mud. So then, who will be the first protagonists to use and assemble all the building blocks offered in abundance in mud? Only those organisms endowed with chlorophyll are able to transform solar energy into chemical energy. These are the same microscopic cells, algae, that are found in all aquatic environments. The difference here being that they live in mud.
I'm collecting algae that have developed at low tide in the sun, and then we're going to be able to see, at greater magnification in the laboratory, how these algae are able to move around in this sediment to be constantly in the sun at low tide.
However, for the first essential step of photosynthesis, time is precious and above all counted. A veritable race against the clock begins. Indeed, even if all the ingredients are in fact present, some are not always available. At night, there is no sun, so it is not possible to assemble the building blocks, although they are there. Besides, even in the daytime and in full sunlight, night reigns just a few centimeters below the surface of the water, so heavily is it loaded with clay. The greatest chance these mud algae have is the moon. As the moon revolves around the Earth, its mass attracts the water of the oceans, leading to the periodic retraction of water from the coast. These are tides. The mudflats are thus uncovered at low tide and are metamorphosed by day into a fantastic transformer of energy, creator of life. The microscopic algae proliferate and concentrate themselves on the surface of the mud, an individual strategy which will be reproduced by millions of cells and which will lead to a gradual change of color of the entire mudflat as the hours pass. These algae are known as diatoms. They are the first to synthesize carbohydrates, the fuel of life, which are subsequently avidly used and reused by the entire food chain. However, the scientist wonders, how do the diatoms avoid being buried under the new deposits of mud? For the diatoms have no choice. It is absolutely essential for them to be able to rise to the surface to capture the rays of the sun. Not an easy task for these poor algae, without limbs or brain, to find a solution. They initially opted for the ideal morphology for moving around in viscous environments like mud. They have a very elongated shape and can therefore slide between the microscopic particles of mud. That's all very well, but then what is their means of propulsion, especially since they have a totally rigid silica skeleton? The researchers' strategy has proved fruitful. The possibility of examining samples just minutes after they have been taken has given him the opportunity to observe living diatoms moving individually between particles of clay. Most importantly, he has noted that these migrations take place independently of the circulation of water, so it is a matter of voluntary and active movements whose sole function must be the search for light. Even more astonishing, and it's a first for the researcher and perhaps even the scientific community, he has discovered rigid filaments in various parts of the diatom's body. Could this be the algae's means of propulsion? Daniel has just found a solution to one mystery, which obviously leads to new questions. These organisms, although considered primitive, are nevertheless capable of extraordinary adaptation and ingenuity. A finely worked shell makes up the skeletal structure of diatoms. It protects the chloroplasts, tiny colored chlorophyll-containing elements. And it is here, inside these minuscule yet highly sophisticated factories, that the fundamental process of photosynthesis, which radically revolutionized the conditions of life on Earth, takes place. Chlorophyll has the amazing ability to capture solar energy for glucose production, using carbon dioxide and liberating oxygen. As the tide rises, the diatoms, once they have taken their fill of solar energy and stocked it in chemical bonds, plunge deep into the mud with one precise aim: to replenish their stocks of nitrogen and phosphorus. Using these building blocks and consuming part of the energy they have accumulated, the diatoms go on to produce the molecules that are essential to all, but that only they know how to assemble. Thus continues the cycle of tides and days. In the sun and at low tide, energy trapping and fabrication of the fuel, carbohydrates. In the dark and in the mud, assembly and construction of the molecules of life, proteins and nucleic acids. In the mud of Guyana, who is the first to consume these algae and rob them of their precious carbohydrates? A living organism, totally incapable of photosynthesis and quite astonishing. The protozoan, consisting of a huge single cell that contorts itself in an extraordinary manner, making acrobatic movements. Its body is surrounded by a great many vibrating cilia that enable it to track down its prey. Good luck is with Daniel Guiral, since for the second time in just a few days, his idea for the floating laboratory has provided him with another scientific first. Via the microscope, the researcher has succeeded in detecting diatoms inside living protozoa. Perpetually hunting, guided by a most mysterious instinct, these large protozoa explore their environment, relentlessly gobble up diatoms, despite their size and rigid skeleton. The most voracious can even swallow two at once. Next begins a period of slow digestion, the sole end of which is to appropriate the energy stores and the patiently produced molecules. For some of these protozoa, the diatoms are in the process of being digested. For others, everything useful has already been taken. The skeleton has been expelled, and after a very long period of chemical dissolution, it will join the stores of dissolved silica, enabling the construction of a new diatom at a future date. From this point on, this highly precious organic matter will be passed continually from one living organism to another, from one predator to another, from the weakest to the most powerful, from the least armed to the best armed, and all with one universal objective, the frantic race for survival. This imperious life force permits all sorts of cruel behaviors, but also, for the weak or less well-armed, the most incredible strategies and ruses for taking advantage of the slightest opportunity. Diatoms, like protozoa, are single-celled organisms. Lacking all defenses, they constitute the prey of many predators, which ruthlessly chop them up and swallow them, robbing them in turn of the treasures they have so patiently produced. These are the actors who now enter the scene and form the vast world of the microscopic fauna of mud. Numerous species coexist in the surface layer of the mud, dominated by primitive worms, nematodes, and various species of tiny shrimp, the zooplankton. And of course, all these species have the same morphological adaptations. A compact, spindle-shaped body adapted to a world in which the space available for free movement is limited. The similarity in shape of the different forms of mud life is of course not a matter of chance, but of necessity. These predators are much more complex than the diatoms and protozoa, since they are composed of a mosaic of specialized cells organized into multiple organs, each with its own special function. The individual success of these cells is therefore no longer dependent on the individual, but on the success of the entire organism of which they are a part. For the first time ever, the scientist succeeds in observing the jerky transit of the precious organic matter as it passes through the digestive tube of a transparent organism. In this mud, still uncovered by the tide and exposed to the sun's rays, an incredible microscopic life flourishes. This colossal quantity of living matter, spread out as an offering over dozens of square kilometers, attracts a crowd of opportunistic consumers, whose size has nothing to do with the mud's fragile inhabitants.
Here it is. Look, it's a female.
Among the most active, the crabs, who will devour without distinction this entire tiny world, diatoms, protozoas, zooplankton, without a second thought. Hidden in their burrows at high tide, the crabs appear as soon as the water recedes. Barely emerged from the mud, they have one obsession, for their time is counted: to ingest as much organic matter as possible before the water returns. This species of crab, Uca maracoani, is also known as the fiddler crab. A true perfection of nature, this crab is perfectly adapted to soft mud. Half terrestrial, half aquatic, both a walker and a swimmer, when it buries itself in the mud, it is always voluntary. The males are endowed with an enormous pincer, either on the right or the left, which serves as a powerful earth-moving tool for maintaining their burrows. This voluminous and cumbersome organ has a special social function, marking their territory and attracting females. But how do they distinguish between mud and organic matter? Especially since their food is at their feet, and their eyes, situated on the end of retractable windscreen wipers, can only visualize the sky. There is not enough time, and it is impossible to sort with the feet or to think. They must act. At a mad pace, the crab grabs blindly at the whole superficial layer of mud, there where life is concentrated. It swallows everything, and the selection takes place in its mouth. The organic matter is ingested while the clay is spat out and rolled into little balls under its mouth. Periodically, and before it is hampered in its fervent feeding activity, the crab relieves itself of the clay with astonishing agility, depositing it on the mud in a fraction of a second. The The crab is thus the first to carry out a new stage in the construction of life. The fabrication of organic matter changes direction here. Its transformation into muscle represents the passage from the microscopic to the macroscopic scale. The females, with their two tiny pincers, appear to be less well endowed than their male counterparts, but their pincers are really functional. The scientist has observed that the male's investment in an enormous pincer is not without risk. It takes twice as long for a male to feed than a female, and the risks facing them outside their burrows are huge. Fiddler crabs with their armor appear to be invincible warriors. However, there is a formidable predator that lies patiently in wait for them, waiting for low tide when it knows that the crabs will inevitably come out into the open. The danger comes from the sky, and Daniel now understands the importance of the crab's periscopic vision that ignores the ground, since in any case the resources are available everywhere. Beneath its armor, the crab's flesh is delicious. Even the pincer, the pride of the male, representing half of its body weight, is swallowed. The hawk's digestive juices are able to dissolve the thick shell, which in fact provides poor protection for this coveted flesh. Thanks to the energy and amino acids contained in the crab's flesh, this hawk will be able to synthesize in turn the muscle fibers whose amazing strength will allow it to escape Earth's gravitational attraction. As for the crabs, impotent when faced with this ruthless predator, they have already long opted for a strategy of numbers, thanks to a very high fertility rate. On average, more than 50,000 eggs per female at each egg-laying session. Periodically, the crabs go looking for small pools of water to rehydrate themselves and to maintain their organs, despite the mud, in a perfectly functioning state. After several hours of feeding, the crabs become immobile, their backs to the sun, in a surprising position given that this behavior exposes them to their predators. For the scientist, this could be explained by a sort of paralysis due to their prolonged respiration in the open air, leading to the tetanization of all their muscles caused by the accumulation of lactic acid. A new category of predators also takes advantage of this abundance of food made available by the efficiency of diatoms. A more aesthetically pleasing category, quite visible this time to humans, and very well adapted to this environment: the mudbirds. This is the real visible and obvious wealth of the Guianan mudflats. An incredible ornithological diversity, including the red ibis, snowy egret, tricolored heron, osprey, small migratory waders, and the rarest pink flamingo. Each species has developed its own technique for obtaining its share of food with the least possible competition. The diggers, with their long feet and legs, dig with their curved beaks, the ideal instrument for detecting prey in the soft mud. The small waders do like the crabs. They dig blindly in the superficial layer of the mud. As the tide withdraws, some aquatic visitors are left stranded. Small fish and young shrimp, imprudent ones who failed to leave the mudflat in time and whose lives end there prematurely. The living matter stuck in the mud or trapped in pockets of water are not lost, but enable other lives to continue. Each of the species present has developed its own strategy as a function of the arms it possesses, thus enabling it to share resources without competition. The lives of all these predators follow the rhythm of the imperturbable cycle of the tides. But the time the diatoms have at their disposal for enabling all this profusion of life is extremely short, since it is limited to periods of low tide and daylight hours, as long as the sun is shining. Despite this restriction, the mudflat constitutes an exceptional larder, going by the density of clients present in the terrain. The nourishing mud presents another undeniable advantage. Apart from Daniel Guiral and his film crew, few terrestrial predators dare to venture into this soft, imprisoning matter. Jaguars, ocelots, caimans, and anacondas therefore keep their distance. As the tide returns, every square centimetre is explored. The utilization of the organic matter is optimal. A mysterious ancestral alert signals the end of the feast. The crabs remount the mudflat with just enough time to fix up their burrows. Then, using the compact and waterproof mud, they close the door behind them and go off into the depths of their burrows to digest all that they have ingested. After copulation, the male abandons its burrow to the female, who remains walled up for 2 weeks, the time necessary for her eggs to mature. She thus ensures the future of the species, sheltered from all predators. The birds exploit the mudflat to the very last moment, leaving the nutritious manna only when their legs become too short to protect them from the attacking waves. They then fly off to take refuge on land and await the next low tide. In this magnificent dance that nature offers to the informed observer, the water rising with the tide provides 2 new populations with the opportunity to feed: fish and shrimps. Yes, but what have the crabs and birds left? Not a lot, so the only solution for these famished creatures is to penetrate as far as possible into the many channels that enable the mudflat to drain at low tide. Remounting the channels is full of risks and only profitable if it gives access to very abundant resources. The first to penetrate the mudflat with the rising tide are some quite bizarre fish, ideally adapted to their living environment, the anableps. In Guyana, they are called big eyes. With a brusque tail movement, they propel themselves across the mud. Their thin feet then give them a definite advantage over other aquatic competitors. They are thus the first, and for a short time the only ones to feed on the communities living on the surface of the mud. These extraordinary amphibian fish avoid all predators thanks to their eyes, which enable them to see simultaneously below and above the water. Their eyes are situated on the tops of their heads like a periscope. Although the white egret is perfectly aware of this, it is tempted by the fish, but with no great conviction. The scientist wants to assess the importance of the nutritional role of the sections of the mudflat furthest from the shore, in the places where the crabs and birds do not go.
We're pushing a net which intercepts all the fish that want to feed on the mudflat, and so we use the outgoing current.
During high tide, the sea penetrates the interior of the mudflat, taking fish and shrimps with it. Now, as the water recedes once more, all these fish and shrimps must return to the ocean. This time, they will be captured in the scientist's net.
Yes, there are lots. Go on, lift it. Everything that's in the net, these are fish that have been caught during the past 2 hours of outgoing tide. It looks like there are lots and lots of juvenile fish, which is quite logical. This small adult fish or its juveniles then serve as prey to all predators. That is, much bigger fish, which do not penetrate into the mudflats, but in fact wait for the outgoing tide to feed, especially on this fresh flesh produced on the mudflat. At the bottom, there are shrimps, which enter the larval and juvenile stage in the mudflats, and in the adult stage, return to the sea where they reproduce. And so this is one of the very important functions of the mudflat. It serves as a nursery for these shrimps. And without mudflats, well, all these beautiful adult shrimps that we can buy would not exist, and they are totally linked to this type of environment.
With the cycle of the tides beating the rhythm, the food resources of the mudflat are shared between two communities: the birds and crabs at low tide, young fish and shrimp at high tide. In parallel with the animal life that proliferates thanks to the mud, another just as essential phenomenon has appeared: the colonization by the forest of these new deposits of Amazonian sediment. But what are the mechanisms? The appropriation by land plants of the coastal zone has long aroused the researcher's curiosity. Simple and regular observations will enable him to demonstrate the process, as yet poorly known, by which vegetation conquers the mud. Once again, the sun is a determinant factor. A little more sediment deposited here and there by the high tide and all will change. If the mud rises just a few millimeters above the water level, it will be exposed more to the sun and wind. It will then dry out and crack. Mud cracks will appear. They will soon become traps. The mangroves that border the mudflat form the mangrove forest, an astonishing type of forest in which extraordinary trees have adapted to taking root in soil that is both salty and unstable. The dominant species of mangrove in Guyana is the Avicennia. This tree has invented a remarkable system of reproduction. Its seeds can float, which enables them to leave the shaded areas where they would have no chance of taking root, since all the solar energy is absorbed by the leaves of adult trees. The seeds are taken up by the rising tide, then carried out towards the sea when the tide ebbs. They are beached a little further away on mud banks exposed directly to the sun.
There are thousands of Avicennia seeds that have been produced by the adult mangrove, removed by the outgoing tide, and are now in the phase of returning with the incoming tide. We have continuous trails of seeds which are transported by the current and deposited on the beach in bare areas where the plants can develop, whereas in the interior of the mangrove forest, without light, these seeds are unable to develop at all.
They will be taken up again by the tide, and so it goes on, back and forth. All? No, almost all. Some will be definitively trapped in the mud cracks, while all the others will deteriorate gradually. The few seeds trapped in this way will find themselves in the ideal conditions for germination. Sunlight, thus energy, but also organic matter trapped in the mud cracks. This young shoot is just a few days old, but it has already managed to take root sufficiently to resist being washed away by the waves. After just a few weeks of colonization, the thousands of tiny shrubs now packed together will bring about a totally new condition: shade. The plants will absorb almost all the solar energy through their leaves, and very few sun rays will be able to reach the mud. Immediate consequence? Deprived of the energy source, the diatoms at the bottom of the food chain will be gradually eliminated. This will lead to the migration of all the species that feed on diatoms. Little by little, the life leaves the mud, whereas before all these trees appeared, it flourished there. Moreover, this mud contains very little oxygen, being composed of totally airtight clay. No exchange with the air is possible. To compensate for this lack, the mangrove sends up aerial roots that enable it to take oxygen from the air like a diver's snorkel. They grow everywhere. But this remarkable adaptation is far from sufficient, since the mangrove, like all plants, needs water. But at the seaside, the water is salty. So, to be able to pump in this water, the mangrove produces tannins, complex molecules that allow it to exceed the salt concentration of seawater. However, by pumping this water, the salinity of the sap of the Avicennia is so high that it could be harmful to the plant. The tree has developed a parry that appears simple but is extremely sophisticated.
On these leaves, we can clearly see these translucent crystals. Yes, it has a salty taste, it's sodium chloride. And in fact, it's associated with the quite surprising ability of this plant, totally unique, to have created salt glands which enable the plant to extract the salt that it pumps at the level of its roots, in the seawater. And the rain comes along to wash the leaves and reset the salt extraction system to zero. And so this species is found to be very, very dominant in Guyana because of this adaptation.
However, the very high concentration of tannin that enables the tree to absorb salt water has definite consequences in this forest. All its leaves are highly toxic. This strange fact is blatantly obvious to the researcher. All these toxic leaves, but there are practically none at the base of the trees, which is rather surprising in a forest. The very high density of trees and the innumerable aerial roots should prevent the leaves from leaving the mangrove forest on the ebb tide. And yet the scientists have never observed great quantities of leaves on mudflats. There must be an explanation somewhere. The few fallen leaves are totally intact. Logical, since they are poisonous. No bacteria, fungus or insect, and much less mammal, would risk eating them. In this mangrove forest, no obvious animal life, just the sound of the wind rustling the leaves. Whereas in the mud, just a few meters away, thousands of crabs and birds are bustling about. Could animal life stop so abruptly here? But surely there is animal life here. Yes, there is a crab, the Eucydus caudatus crab, much more imposing than its fiddler neighbor. But does this crab know what it's doing? Will it be poisoned by the leaf it's carrying? This crab is obviously taking advantage of the low tide to stock up on mangrove leaves. Does it eat them without taking precautions? Daniel decides to explore a burrow with a fiberscope to understand this behavior that intrigues him.
Straight ahead, and you can see it there. Yes, look, we're there, we can see the pincer. Straight ahead. We're going to try to steal its leaf to pass across the top of its shell. It's decomposing organic matter. For the lab.
The scientist's microscopic observations provide him with the solution. It is in fact not the leaf that the crab eats, but the fungi and bacteria that develop on it. After stashing the leaves in its burrow, the Eucydus crab waits patiently until they have decomposed. In fact, there are deep in the mud some extremely efficient bacteria and fungi that can destroy the toxic leaves by fermentation. So it is the Eucydus crab and its fellow creatures that collect all the mangrove leaves. The continual burying of plant matter enables the mangrove forest to progressively increase its stores of nitrogen and phosphorus. With remarkable adaptations at its disposal and without competition, This mangrove forest that has grown with dizzying speed is now dying of old age, condemned by the shade of its own leaves, despite the increasingly fertile soil. Without sunlight, the seeds cannot grow and thereby renew the forest. All life has abandoned it. Often regarded as an example of wealth, it is in fact nothing more than a biological dead end.
We have arrived at the end of a cycle that finishes, after very great wealth, with this phase of poverty, without life, without birds, in almost absolute silence. It's the end.
These thousands of tons of cellulose that nobody wants will gradually sink into the mud. In a few million years, perhaps new oil wells will spring from the fossilized organic matter. Meanwhile, however, the mud will have fulfilled its role to perfection, a determinant role in the creation of life, enabling the synthesis of billions and billions of molecules and the development of a great number of species, from the simplest microscopic protozoa to the most sophisticated of predators. A process that began more than 4 billion years ago and which continues today before our very eyes. There was once a wetland, as there have been many on the planet for a very long time. Then humans came along and sentenced the wetland to being drained, dried out, filled, to becoming useful at last. On the equator in South America, French Guiana has not been spared this phenomenon. For dozens of years, and despite the appalling living conditions, slaves were sent to the core swamp to grow rice in this immense wetland close to the Brazilian border. With the end of slavery, the rice fields were returned to the wetland, and only a few signs of human determination remain. Nevertheless, in the heart of the wetland is a pond which has been totally ignored by the planners and developers. A sort of tiny paradise where life appears to flow along in a state of perfect harmony. It is here that some astonishing and rare inhabitants have chosen to live. Birds, reptiles and plants that exist nowhere else. A kind of sanctuary for rare species. This pond had never been penetrated by humans, and with good reason. It was once totally inaccessible, situated in the heart of an immense wetland of floating grass, itself surrounded on one side by impenetrable jungle and on the other by formidable mudflats. This totally unknown pond is about to reveal its most intimate secrets. One day, a mammal never before seen in the vicinity and accompanied by several fellow creatures arrived by the only possible route, the sky. A rare species too, scientists. Neither fish nor frogs, they established themselves in a sort of house placed on the water, which was soon to become a floating laboratory, sheltering numerous predators who were rather curious about, if not intrigued by, this intrusion. At the head of this small group, Daniel Guiral, researcher at the Development Research Institute and specialist in aquatic ecology. Long intrigued by this pond, which he had previously only been able to fly over, Guiral arrived with the firm intention of deciphering the strategies adopted by the inhabitants of this little paradise, which was about to reveal a world governed by a very subtle state of equilibrium and relying on laws of extraordinary ingenuity. Water is obviously the dominant element in this aquatic ecosystem, but where did it come from? In our conquest of the planet, we humans learnt to take advantage of the winds, particularly the trade winds that blow permanently in the same direction, leading directly from Europe and Africa to the Americas. These winds carry with them enormous clouds, the cumulonimbus, formed by the condensation of water evaporated from the surface of the Atlantic Ocean. The trade winds converge on the east coast of the South American continent. The first barrier encountered by these masses of humid air is a hill barely 350 meters high on the coast of Guyana. Here, in an almost flat landscape, it is called Core Mountain. In fact, despite its low altitude, this hill does indeed play the role of a mountain by causing the brusque halt of the clouds and very intense equatorial rains.
We are now on the Core Mountain track, which leads over the pass at an altitude of 330 meters above sea level, in the zone with the highest rainfall in Guyana. Every year between 4 and 5 meters of waterfall here.
All very well. However, all this water that falls from the sky in an enormous quantity runs over ground that is practically devoid of soil, for the mountain is an immense metallic shell composed of iron oxide. The water carries nothing with it, and therefore none of the elements indispensable for the development of life. When the water reaches the base of the mountain, it is still rainwater, totally pure. This mountain is in fact the vestige of very ancient and immense volcanoes that were in activity before the separation of South America from Africa. Worn down and washed of all its soil, this enormous slab of highly compact iron is covered by a forest in a state of survival despite its appearance, since it grows in extremely poor soils and can rely only on its own litter for regeneration. The roots of these trees run along the surface and attempt to penetrate the shell in search of nutrients and water. The roots may extend for more than 100 meters without finding what they seek. This mountain is incapable of retaining rainwater, which pours into an immense basin over 70 kilometers long, spreading out over 40 kilometers as far as the ocean, the core wetland. The absolute purity and, more importantly, poverty of this water is not a good omen for the development of life in the wetland, since it contains no nutrients. The wetland is covered in floating vegetation, which prevents gaseous exchange between air and water, and moreover considerably limits the amount of light that can penetrate the water. Without light, photosynthesis is impossible, and thus there is no oxygen production in the water. In addition, the slow decomposition of the plant cover consumes the little oxygen that was dissolved in the water as it ran down from Core Mountain. This pond, a simple tear in the plant carpet, lacking in nutrients and oxygen, does not seem very favorable to supporting life. And yet, an astonishing fauna has obviously chosen to live here. How do all these inhabitants manage to coexist in this closed space, isolated in the heart of an immense flooded prairie? The water is not only poor in oxygen, it is acidic due to the decomposition of plant matter, one more obstacle to the development of life.
Come on. Right. So here I'm going to filter the water to retain all organisms bigger than 40 microns.
The scientist nevertheless manages to observe several very rare algae hidden in the decomposing organic matter. Nevertheless, it is algae that form the first link in the food chain. Under the microscope, they reveal all their beauty. They are veritable jewels. They are so few in number that their role is quite negligible compared with the water lilies that cover practically the entire surface of the water. These plants intercept most of the light and take up the little nitrogen and phosphorus available in the environment. Well then, how can a food chain like this function, culminating in such powerful predators as the black caiman and relying at the outset on such a low concentration of algae? In this very special water, Daniel has successfully demonstrated that microscopic aquatic life is present, although poorly developed. Yet several species of living organisms managed to survive in this biological near desert. The smallest organisms are the zooplankton, which, feeding on algae, usually constitute the second link in the food chain. The problem here is that the algae are not only very rare, but they are much bigger than the zooplankton, which consequently cannot eat them. Several other organisms, the rotifers, are also present in very small numbers. Here they are so small that they eat mostly bacteria, which they suck in using a clever system consisting of a double crown of cilia turning in opposite directions. In this amphibian world where plants dominate, even birds have had to adapt. Among the pond's residents, the jacana is a specialist in walking on unstable terrain. Supported by the lily pads, it is forced to move continually so as not to sink. However, having little gratitude for the plants that allow it to walk on the water, its behavior shows a lack of respect for the flowers of these water lilies. For this bird, considered to be an insect eater until this first observation, the nitrogen-rich seeds of the water lily constitute an indispensable dietary supplement in this very poor environment. A strange bird populates the sides of the pond. the Hoatzin. It is so well adapted to this plant-dominated world that it has become a vegetarian. Looking like a living fossil, the bird eats leaves exclusively. The trees thus provide not only its perches, but its food as well. To be able to assimilate the leaves of the toxic and indigestible Pterocarpus tree, which makes up the major part of its diet at the pond, the Hoatzin has had to develop a digestive system that closely resembles that of ruminants. Very selective in its diet, it chooses exclusively the youngest leaves on the end of the branches, the least coarse, a perilous exercise in balance for this heavy bird. Its hypertrophied stomach, which accounts for a quarter of its body weight, is responsible for the significant atrophy of its wing muscles. Jumping and gliding more than flying, its ability to move around is very limited, but without serious consequences. Indeed, what would be the point in being able to leave the pond when the Pterocarpus grows only at the pond and nowhere else? In this chain of adaptation and behavior, it is now very difficult to determine whether the Hoatzin became a leaf eater because it is a bad flyer, or whether its adaptations for digesting the leaves have imposed a sedentary lifestyle on the bird. Because of these now irreversible choices, the life of the Hoatzin at the pond is completely dependent on the young trees that colonize the banks. This vegetation is regularly nibbled and produces a large amount of dead wood, which has some highly unexpected consequences. The little egrets that occupy the tops of the trees are birds with a much more classic diet. But this impoverished pond can offer no resources to its tenants. The scientists' observations indicate that it is a calm and isolated dormitory where it is possible to rest and reproduce in complete peace. Each morning, the colony of egrets takes off in extended order to fish in waters where the fish are both abundant and more accessible. All these observations only render the paradox of this pond more incomprehensible. The extreme poverty of the water is in total contradiction with the presence of super predators such as the black caiman. It is the scientist's curiosity that provides him with the first key to understanding. Between the wide lily pads, Daniel Guiral has noted the presence in various parts of the pond of timid and fragile little yellow flowers that emerge from the surface of the water.
Can you see that? Just there, next to that lily pad? That delicate little flower there.
Still more surprising, these flowers are attached to very large yet invisible immersed vegetal masses. They present a highly complex organization with branches of a very bright green color spreading out below the surface of the water. And deeper down, very long brownish branches covered with small vesicles enveloped in a gelatinous substance. The contrast between the green surface branches and the brown deep branches, where you would expect to find roots, is remarkable.
These are not roots. So you can see all these little vesicles, these little transparent balls.
What is this plant then, since these are not roots and the plant floats freely on the water?
This is quite surprising. Inside you can see little prey, still alive, that have gone inside these sorts of traps. So here we're dealing with a carnivorous plant. It has a double function, that of a chlorophyllic plant, which explains these green branches, and it also feeds on living prey.
These carnivorous plants are called Utricularia, bladderworts. This aquatic plant has developed a quite astonishing strategy, task specialization. For its surface branches, the classic activity of photosynthesis, and for the deeper branches, the capture of living prey. Thanks to the zooplankton they capture, these carnivorous plants find the nitrogen and phosphorus indispensable to their survival, although these elements are practically absent in the water. Each sac-shaped trap has two big branching antennae which serve to direct the prey towards the valve that hermetically seals the trap. The capture is set off when the sensory hairs around the entrance to the trap are touched by the prey. This information leads to a reflex action that opens the valve. When the valve opens, water and prey are sucked in. Followed immediately by the closure of the valve. These steps take only 10 to 15 thousandths of a second. However, the scientist has another question. How can this intense predatory activity be explained when the prey are so rare in the water? These carnivorous plants nevertheless remain plants and are immobile in stagnant water, unlike carnivorous animals that can track down their prey. What do they do to trap zooplankton? There are indeed some rare carnivorous land plants that also live in very poor environments. It is their odor or their color that attracts insects into their traps. But as for our wetland bladderworts, how can they be plants, carnivorous, and live permanently underwater at the same time? Only one solution. They must have a strategy for bringing the zooplankton close to the traps.
What interests me is describing the species. So the aim is to have the largest samples possible to get a good representation of the entire community living in this water in immediate proximity to the plants.
The researcher notes that in effect the concentration of zooplankton is much higher in the immediate vicinity of the carnivorous plant's traps than in the water of the pond. This concentration cannot be due to chance and must certainly be the result of a strategy established by the plant and directed at the zooplankton. On the branches of the plants and on the traps, Daniel notes the presence of fixed algae that are much smaller than those he observed under the microscope at the beginning of his mission. tiny algae, perfectly adapted this time to the size and diet of the zooplankton. The scientist then realizes that the plant allows itself to be colonized by algae in the sole aim of attracting zooplankton, to capture them as soon as they pass close to the traps. This behavior had never before been observed in this plant. Daniel now understands the meaning of the elevated concentration of zooplankton near carnivorous plants. It is logical. The zooplankton is there where it can find food, even if it is not without risk. The carnivorous bladderwort plants maintain a sort of kitchen garden, an exceptional strategy. It's exactly as if a lion cultivated a garden in the middle of the desert to attract and fatten up gazelles before eating them. What has never been seen in a desert on land exists here in the heart of the core wetland. As a result, this luxuriant kitchen garden and its inhabitants interest a whole range of curious fauna attracted by this godsend. Dragonfly larvae, which prowl around relentlessly in search of prey, and another very strange animal, the larvae of the caddisfly, which resembles a butterfly in the adult form. To protect itself from predators, this larva builds itself a case using secretions from its salivary glands. At the approach of this dragonfly larva, the caddisfly larva retreats inside its case and stops moving, an effective camouflage since the predator continues on its way, thus missing a prey of a size fitting its formidable appetite. The caddisfly larva, by eating the algae that develop on the branches of the carnivorous plant that have become too large for the zooplankton, thus ensures the regular maintenance of the kitchen garden. Another strange animal, the phylopod, also takes advantage of the abundant food in the bladderwort plants. This primitive pearly crustacean has feet with multiple functions. They undulate in a synchronized fashion for its respiration and to enable it to swim. The female shelters her young under her translucent shell. They are released only when their mother dies or molts. Look, a traveler has just landed. It's a Muscovy duck, and apparently it's interested in the pond. Almost immediately after landing, it starts poking around with its beak. It chooses our carnivorous plant. Is this a matter of chance? Probably not, since this selection represents a complete food, one which will satisfy all its needs. If this jousting match between two males for the attention of a female is any evidence, they seem to appreciate this sight, in spite of the more than menacing presence of caimans. But it is not just Muscovy ducks that are attracted to this pond for breeding. A new, quite extraordinary event is about to suddenly upset the fragile system. the arrival of new tenants, and not ones to be ignored. The scientist discovers that this sanctuary is not only one of the last places of refuge for the black caiman, but before his very eyes it is becoming the largest known breeding site in the world for an extremely rare bird, the agami heron. With his teammates, he witnesses the arrival en masse over a few days of these magnificent, poorly known birds that install themselves by the hundred in the trees bordering the pond. The ornithologists will count more than 5,000 of them.
We are really entering the sanctuary of the agami now. So here are these superb herons, and we have just about all the stages of development of the chick, the nest, the eggs. This really is quite a fabulous bird, and it is so rare that up to now we knew nothing about its ecology, its biology.
There begins immediately an above-water ballet under the watchful eyes of the caimans. The birds fetch small branches and build their nests. Where do they find this dead wood? On the trees, weakened by the constant nibbling of the hoatzins. Thanks to these leaf-eating birds resident throughout the year, the site offers enough dead wood for the construction of thousands of nests. Daniel Guiral has just demonstrated a previously undocumented role of these birds. The hoatzins' nibbling has modified the environment and made it attractive to another species, the agami heron. Barely have the agami herons settled in when another heron species arrives in turn, the boatbill heron. However, to build its nest, the boatbill does not use dead wood. With its powerful beak, it breaks young leafy branches. The competition with the agamis is thus limited to the search for available space in the trees for establishing their nests. So a new question arises. What are these new immigrants and their chicks going to eat, since this pond functions only through subtle exchanges, enabling the maximal utilization of the few available resources? The ornithologists who have come to join Daniel Guiral are going to attempt to solve this riddle. The agami herons, the most numerous, are essentially nocturnal in their activities. During the day they take care of their nests, consolidating them, sitting on their eggs, defying each other. Not once do the scientists see them fishing in the wetlands. But at night, using infrared equipment, the ornithologists are going to observe the activities of this colony over several nights.
Look, there is one coming out and it's heading straight west. That one, straight west. And well, we're not getting anywhere with the figures, so obviously the birds must remain several days in the colony. This is all a bit strange. We were told that about 350 birds had entered, with a maximum between 8 p.m. and 9:30 p.m. Then it dwindles down. Towards 11 p.m. there's nothing much more. But they aren't going back and forth each day. It's not possible. We would see many more of them. It would be very surprising, really surprising, because in herons, especially with small herons like these, in general there's a daily feeding. Oh well, yes. One more question to resolve, but here I think we're on the right track.
The ornithologists will discover that each of the two parents in turn goes to sleep on a branch close to the nest. While the other leaves the pond for 2 to 3 days, returning to feed the chicks by regurgitation in the early morning, exhausted after having flown probably hundreds of kilometers. This previously undocumented behavior of the herons is also the confirmation that not one of the thousands of birds feeds in this pond, lacking in food resources. There are still more surprises for the scientists. A new colony establishes itself several weeks after the agamis and the boatbills. They are the American anhingas, whose reproduction had never before been observed in Guyana. The light brown females and the males with their superb black and white plumage build their nests together on the rare shrubs still available. These big birds, very skillful flyers turning about high in the sky with no apparent effort, also have webbed feet which enable them to swim and chase their prey under the water. Their webbed feet also have claws for a better grip on the branches. Equipment perfectly adapted to the daily lives of these formidable fish catchers who detect their prey from the sky. The ornithologists observe in these birds a behavior resembling that of the little egret. The anhingas regularly leave the pond to go and fish and return to feed their chicks by regurgitation. Space is starting to lack around the pond, which is decidedly a most popular breeding site. The trees are so fully occupied that territorial conflicts break out both within and between species. The colonies of little egrets, agami herons, boatbill herons and anhingas have caused a situation of overpopulation around the pond that was so tranquil just a few weeks before. It is quite obvious that the pond cannot feed the whole crowd. It is therefore for its absolute isolation and safety that these thousands of birds have chosen the site. No terrestrial predators, such as monkeys or iguanas, which would ravage the nests if they got to them, take the risk of venturing into this zone. The black caimans are the best guarantee of this safety. The powerful masters of the place, they circulate endlessly around the bases of the trees. Nevertheless, this constant surveillance implies the sacrifice of certain individuals. Mistakes are unforgivable. Falling from the nest is fatal. It is in a way the price to pay for this efficient surveillance. And beware the young heron that returns to the wrong nest from its first explorations, for the owner's punishment may be immediate. The small proportion of birds that fall from nests constitutes an important source of food for the caimans and partly compensates for the poverty of the pond. The arrival en masse of these migratory birds in the trees surrounding the pond is very likely to change the situation. The sudden integration of thousands of immigrants is never without consequence, whatever the society. These thousands of birds are going to produce an enormous quantity of droppings. This matter, known as guano, is a major fertilizer that contains all the building blocks necessary for life, and in particular the most essential, nitrogen and phosphorus. The importation of these elements changes completely the autarkic situation that once dictated how the pond functioned.
You have to approach really very quietly.
With these additional nutrients, will the pond emerge from its situation of extreme poverty?
So here we are going into the phosphorus zone. We're going to be able to verify this hypothesis about the bird's role in the overall functioning of this environment in terms of the contribution of the droppings of the adults as well as the chicks.
In the samples he has studied, the scientist notes that there is still very little life in the water, even though it now contains a lot of nitrogen and phosphorus. All the nutrients fallen from the trees are useless because they are not usable. Indeed, it is the rainy season, and while the washing of the leaves and branches of the trees is intense, the over-dilution of the bird droppings and the absence of sunlight render their utilization by algae impossible. So nobody benefits from the manna, which remains desperately unusable, not even by the carnivorous plants, which in any case have no need. Their strategy enables them to live without nitrogen and phosphorus dissolved in the water. But the scientist remains perplexed. This sophisticated trapping technique does not sufficiently explain the healthy condition of the plants in this very poor environment. For, while the plant captures its prey using its traps, it nevertheless lacks a digestive system. The technique of digestion of this carnivorous plant remains totally unknown. How does it benefit from the zooplankton and appropriate the nitrogen and phosphorus? Daniel Guiral is lucky, and it's a scientific first. Deep within the traps of living bladderworts and at very high magnification, he succeeds in observing an unsuspected activity. He discovers a considerable concentration of protozoa swimming inside the trap. At the junction of the head and body of a recently captured mosquito larva, a whole army has entered the breach and invaded the insect larva to digest it from the inside. The traps of the bladderwort shelter the protozoa, to which the carnivorous plant offers room and board. And so these feeble protozoa are able to feed on enormous prey that they would be unable to capture themselves. In return, while they eat, the nitrogen and phosphorus from the prey are dissolved in the water inside the trap. This water is then gradually excavated from the traps, enabling the vacuum necessary for a new capture to be re-established. The nitrogen and phosphorus are thus rejected to the exterior and are used both for the growth of the carnivorous plant, of course, but also to feed the algae that live fixed to the traps, making the traps a little more attractive to future prey. It's as if our lion, lost in its desert, recovered all its own excrement to improve the quality of the grass in its garden. The gazelles would become that much more appetizing and dependent. The scientist has just demonstrated a most astonishing adaptation strategy for dealing with a shortage of resources. In fact, it represents a situation of real symbiosis on a microscopic scale, and with shared advantages, associating two totally improbable protagonists, protozoa and an aquatic plant. This is all very well, but this complex organization that enables life despite the severe shortage of nutrients is about to tumble like a house of cards. It is even going to turn against the plant and cause its death. For the plant's strategy has meaning only in the context of shortage, but a new event is going to upset everything, the arrival of the dry season. The clouds are going to leave the area after several months of rain. The temperature and sunshine periods are at a maximum with very high values, for we are just above the equator. Due to the extreme evaporation, the pond will shrink and draw out all the water from the surrounding undergrowth, highly enriched by the bird droppings. The massive contribution of nitrogen and phosphorus from the droppings of thousands of herons during the wet season will now be used by the algae. Photosynthesis can at last begin in the waters of the pond. The algae will proliferate to such an extent that they soon form veils on the surface of the water. The pond will thus pass from a state of extreme shortage to one of overabundant wealth. The algae that form long filaments are very different from the rare species present during the wet season and that now sleep at the bottom of the pond awaiting better conditions. This brutal passage from one state to another radically different state is very rare in the natural world. It cannot be without repercussions for the populations that live there permanently.
It's the famous carnivorous plant. So, completely covered in filamentous algae. It's going to be interesting to see how it's going to function when all its traps are completely blocked, stuck together with these filamentous algae.
The algae that our carnivorous plant maintains with parsimony for attracting prey will also proliferate, which will have an unexpected effect on the plant. Death by asphyxiation. Its traps are now so encumbered by the filamented algae that they can no longer detect anything. The algae now form an inextricable coating that the prey can neither penetrate nor eat, since the algae are too long. As a result, these algae are no longer attractive at all. The plant's death is inevitable, since it has no way out. The algae keep the plant in total darkness. Impossible for the bladderwort to resort to a classical way of life through photosynthesis, which could pull it out of this bad patch. Even its green branches closest to the surface of the water are in permanent darkness. The plant's remarkable adaptation to a shortage of resources has turned against it completely and become a fatal trap. The plant suffocates, incapable of making use of the nutrients present in abundance in the water. because the entire aim of its adaptation was to be able to do without. But it's an ill wind that blows nobody good, and this profusion of algae and bacteria will constitute, after months of scarcity, an abundant food source for zooplankton, which will also proliferate. The zooplankton, now free from the predatory activity of the dying carnivorous plants, will be exploited by a new, equally hungry community: young fish. The evaporation and concentration of the water in the pond has attracted fish and caimans, which during the wet season had spread themselves throughout the wetland. It is now in this pond that the fish are going to breed. Thanks to the photosynthesis of the algae, the water is enriched in oxygen and the young fish are able to breathe. The migration of fish from all over the wetland to the pond, imposed by the drying out of the wetland, is followed by that of the caimans. Though extremely numerous, they will be assured of regular meals, and the former bird eaters will become fish eaters. Having grown sufficiently vigorous, when the next wet season arrives, the fish will leave with the overflowing water to populate the whole of the wetland. And this is the second fundamental role played by the pond. Whereas during the wet season, the pond is a site of international importance for the nesting of very rare herons, during the dry season, it enables the breeding of fish for the entire wetland. Even more surprising is the fact that these two functions cannot be dissociated one from the other, the link being the bird droppings, which are both a disruptive element for life in the pond and an organizational element for the entire core wetland. What can we learn from this ecosystem, totally untouched by humans? That, confronted with the situation of scarce resources, millions of years of evolution have seen the development of some extraordinary ruses that enable the tiniest photon, calorie, or organic molecule to be used optimally and as profitably as possible. Here, there is no such thing as waste. All these strategies have made it possible for life to establish itself through very different species, on the imperative condition that they undertake to exchange with each other. A remarkable but extremely fragile state of equilibrium has been set up. On the other hand, in a situation of plenty, only a few species can develop, to the detriment of the others. Is this pond not the reflection of human societies which, when poor, invent the most incredibly clever ways of existing, and, when rich, take for themselves all the energy in total contempt of those too well adapted to a situation of scarcity? Throughout the past decades, the slowly growing awareness of the importance of ecology has led to a complete reversal of the image of these formerly denigrated wetlands, which are now perceived as oases of biodiversity that it is more than urgent to conserve.
Ba